Hi everybody. So the purpose of this video is to give you a different way of graphing quadratic equations if your y-intercept is something that's unwieldy. And the example I want to use is the second example from the homework problems, because the y-intercept on this one would have been 33, and that's something that's really almost impossible to graph in almost any grid that you provided. So here's a different strategy to use if you get a y-intercept that's too big for you to graph. So we're still going to go ahead and get our axis of symmetry, which is negative b over 2 times a. So my b is negative 16 over 2 times a, and my a is 2. So that's going to be positive 16 over 2 times 2, which is 4. So that's going to be 4. Now, the axis of symmetry is also the x value of my vertex. So I'm going to make a t-chart here. And I'm going to make 5 points, just like I normally would with our graphing parabola. But I'm not going to do any transformations here. Instead, the axis of symmetry is like the middle of my parabola. So I'm going to put that x value of my axis of symmetry in the middle of my t-chart. And then I'm going to pick numbers around that number and close to it to find other x values on the parabola. So I can plug those in and get y values, get points that are on the parabola. So numbers that are around 4, numbers that are smaller are like 2 and 3, and numbers that are bigger are 5 and 6. And now I'm going to take each of those numbers and I'm going to plug them into the equation for x. So an example would be plugging in 2. So y is 2 times 2 squared minus 16 times 2 plus 33. So let's see, that would be 2 times 4 minus 32 plus 33. So that's 8 minus 32 plus 33. So that's going to be 8 plus 1, which is 9. If I plugged in 3, I would get 2 times 9, that's 3 squared, minus 16 times 3, which is going to be 48 plus 33. So let's see, it's 18 minus 48 plus 33. So it's going to be negative 30 plus 33, so it's going to be 3. If I plugged in 4, I would get 2 times 16, which is 32, minus 4 times 16, which is 64, plus 33. Let's see, that's negative 32 plus 33, which is 1. And then if I plugged in 5, I would also get 3. And if I plugged in 6, I would also get 9. That would allow me then to take those points, plot them 2, 9, 3, 3, 5, 4, 1, 5, 3, 6, 9, and then draw the parabola from there. Now, your domain on any parabola is always going to be all real numbers. Now you can write x as an element of the interval from negative infinity to positive infinity. You can also write x as an element of all real numbers. That's the same thing. The range is going to depend on which way your parabola faces and what your maximum or minimum value is. So if you look at the vertex of this parabola, it's 4, 1. So my minimum value here, because the parabola opens upward, is 1. So my range is all the y values that are bigger than 1. So it's going to start at 1 and go to infinity. I have an absolute minimum of 1, and there's no absolute max. Right? So if you have a y-intercept that's really unwieldy to deal with, go ahead, get the axis of symmetry, use that as a middle point in a t-chart, choose numbers around that, and then plug them into the equation to fill in the t-chart, then plot those points.